Hello and welcome to section 10.1. So we're starting a new chapter. Chapter 10, we're talking about exponential and logarithmic functions. Okay, so before we do that, we're going to spend the first chapter on what are called composite and inverse functions, because these are very helpful when talking about exponential and logarithmic functions. So we're going to start with some definitions. So a composite function, the notation is this. It's like f, a little o, and a g. This is not multiplication. Right. And it's read as f of g of x. Right? So f of g of x. So what it means, f o g and then parentheses x, means that you are plugging in the function g into the function f. Right? So just like you were evaluating, if you're to plug in a specific value of x into an equation, you're plugging like an equation into an equation and simplifying. Right? So let's look at the following example. So we're going to look at example 10.1. So we're given the equations for two different functions. F of x is 4x minus 5. G of x is 2x plus 3. So basically, we're asked to find, in part A, we're asked to find f of g of x. Right, so this means that you are plugging in the g function into the f function. Right? So the procedure for this is you start with the f function. So we have 4x minus 5. Right? But the x gets replaced by g of x. So basically you erase all the x's in the original f function and you write g of x instead. Okay? But you're not going to leave it as g of x. You're going to replace this in parentheses with the equation for the g function. Right? So the g function is 2x plus 3. So this gets replaced by parentheses 2x plus 3. And then minus 5. Okay? So you can see you're plugging in. You're starting with the f function and you get rid of the x. You're replacing it by the equation of the g function, right? So then you do the work, you distribute, we get 8x plus 12 minus 5, and this is 8x plus 7. Right, so basically, this is called function composition. You're composing two functions. All right, let's do part B. Part B says find g of f of x. All right, so you're doing it the other way. You're starting with the g function, which is 2x plus 3, right? And you're plugging in, so you do g of f of x. You're plugging in the f equation into the g equation. So you're going to get rid of the x, and you're going to replace it by f of x. But you are, on the next step, you're going to write parentheses and the equation for f of x. So we have 2 parentheses 4x minus 5, close the parentheses, plus 3. Right? So the f function got plugged into the g function. We simplify, we get 8x minus 10 plus 3, which is 8x minus 7. Right? Notice that these are not the same. Most of the time, they're not going to be the same. Sometimes they will be, but most of the time they're not, right? So basically, sort of, when you're doing composition, you're doing two operations in a row on some input, right? So you are going to think of a function machine. You have some sort of input, which is your x value, right? And you are plugging in, you're sort of putting in this input in the f of x function machine, right? Now f of x is this equation, In this case, it's 4x minus 5. Right? And then when you get the result for this particular input, you're going to get an output here. Right? And this gets plugged into the equation for the g function, and you get another output. Right, so this output becomes the new input. So you can do this for, it doesn't just have to be with two functions. You can keep composing. So just doing operations in sequence. It's like most things we do in life. You know, we do a certain task, but it's composed out of several tasks. Okay, so you get dressed, or you wake up in the morning, and you do several tasks. And those basically functions in composition. So you're getting dressed, right? So I'm getting dressed. I want to put my clothes on. So I can put my underclothes on, and then I can put my pants and my shirt. So the result is that I'm dressed. Okay? Now the order is important, because if I put my underclothes first and then my pants and my shirt, I'm going to end up with, you know, a result. But if I put my pants and my shirt and then my underclothes on, I'm gonna start look at like Supergirl or Superman. So it's right, the order matters. Okay, so you just kind of think of this as a composition of operations. Right? So there's one last thing. Part C says f dot g of x. This is multiplication. So with the little o is composition, but if you just see the dot, that means multiplication. So let's do f times g of x. This means that you're taking f of x times g of x. So f of x was 4x minus 5 times g of x, which is 2x plus 3. So you're not plugging one into the other, you're just FOILing. Okay, so we get 8x squared plus 12x minus 15x minus 10x minus 15, which is 8x squared plus 2x minus 15. Right, you can see that this is different than the others also. But composition is not multiplication. And the order of composition is important. It will usually give you different things. Okay?